This is my second class from hyperbolic trigonometric functions. So in this class, now I am going to explain you hyperbolic cotangent function and cosecant function and secant function. And also I discuss with you whose inverse functions and whose differentiations and whose integrations. So before going to this class, now I am requesting you to subscribe my channel so that my classes reaches to many people. Now let us go to the class. So first I explain you hyperbolic cotangent function. Now let us see whose definition. F is a mapping from r minus 0 to minus infinity to minus 1 union 1 to infinity is known as, is defined by f of x is equal to e power x plus e power minus x by e power x minus e power minus x is known as hyperbolic cotangent function. So simply it is denoted by cot of hx, so which is equal to e power x plus e power minus x by e power x minus e power minus x. So if you would like to consider this one as y, you can. So this is the definition of hyperbolic cotangent function. Okay. Now let us go to whose graph. Now observe whose graph. See, what is the definition of function? F of x is equal to e power x plus e power minus x by e power x minus e power minus x. So we learned whose domain r minus 0. So that function domain contains r minus 0, means 0 is not included into the domain. Okay, why? Because when we write x equal to 0, so denominator e power 0 1, e power minus 0 1, 1 minus 1 0. In the denominator place we are getting 0 in the simplification. Hence, okay, you know, such kind of divisions are not possible. So that this function domain doesn't contain 0. We should not assign x equal to 0. Okay, right. Next, you know how to draw the graph. Okay. So the domain contains r minus 0, no? Means which contains negative real numbers and positive real numbers. First, now I would like to assign x equal to positive real numbers. So when we write x equal to positive real numbers, how do you get the graph? Tell me. Suppose let us begin with like more than 0, like 1, 2, 3, like infinitely many values you can assign. So if you write x equal to 1, here e power 1 plus e power minus 1 by e power 1 minus e power minus 1 you will get. So in this simplification, okay, what kind of result you may get? You know, e value, it is an irrational number, approximately 2.718. okay, so that value if you write here and in this simplification you may get, so that range y value is a very big value you may get here. Similarly, when you put a x equal to 2, you may get here. Like if you put n equal to 3, you may get here. Like that, if you keep on increasing your domain values, so your graph will decrease like this. See, here you may get on the y-axis here, you may get 1 here and minus 1 here. So if you keep on increasing your domain x values, so your range values will come like this. That graph will go like this. Okay, but this result never be 1. Why? So you know, see, if you, here we are moving from left to right. Okay, so if you assign x equal to very big value, means like infinity, what do you get? E power infinity plus e power minus infinity, which can be written as 1 by e power infinity by e power infinity minus 1 by e power infinity. Okay, now 1 by a very big value, this almost approaches to 0. This is going to be 0, this is going to be 0. Am I right? Because in the denominator it is very big value. So you know that approaches to 0. This is approaches to 0. So after it became 0, don't cancel these two. Okay, because we don't know exact result of this. Both are okay equal and cancel it and the result will be 1. Don't say like that. Even because this result is not exactly 0, this is not exactly 0. Just it approaches to 0, very close to 0. Hence we have taken here 0, but not exactly 0. So that what do you comment? Numerator and denominator are not equal. Hence this result never be equal to 1. So this result will be more than 1 only. So you get the graph like this. If you draw a horizontal line through the one, this horizontal line which is representing with the dotted line, okay, should not touches or intersect the graph of the cotangent function. It is very close to y equal to 1 line. You know, this dotted line is a horizontal line, no? So passing through 1, hence whose equation is y equal to 1. So this is the graph of cot hx. Okay, so it is strictly decreasing in the positive interval, but never touches y equal to 1. So y equal to 1 is the asymptote for this cot hx graph in the positive interval. Okay, I hope you have understood how I have drawn this cot hx graph in the positive interval of its domain. Okay, right. Now let us go to the negative real values. How do you get to tell me? Negative real values. If you keep on substituting negative real values for x, so you get the graph like this. Okay, so here also through the minus 1, if you draw a horizontal line, that horizontal line never touches or intersects this graph of cot hx. Move from 0 to left side here. If you reaches minus infinity, so your result reaches to minus 1, but not exactly minus 1, so that you get the graph like this. So move from left to right. Your domain values are increasing, so here your graph is decreasing. Okay students, your domain values are increasing, your range values are decreasing. Here also your domain values are increasing, your range values are also decreasing. Okay, it is a decreasing function in its domain. I hope you have understood the graph of cot hx, whose domain is r minus 0. Okay, so 0, where 0 we got the break in this graph. At 0, this graph is discontinuous. Cot hx is discontinuous at x equal to 0, because in its graph we are observing the gap. Hence cot hx function is a discontinuous function at 0. And whereas range is, see here, minus infinity, this is negative x-axis. Okay, so minus infinity to minus 1, open union 1 to infinity. Okay students, so what is the domain of the cot hx? R minus 0. Range will be minus infinity to minus 1, union 1 to infinity. And also it is a discontinuous function at x equal to 0. And also it is not a periodic function. Now observe the graph of this cot hx. Is this a periodic function in its domain? Is this graph is repeating more number of ones? No. Hence, it is a non-periodic function. Okay. I hope you have understood this. Now let us go to whose inverse function. Now tell me, what is the domain of whose inverse? Tell me, f inverse of x, which is equal to cot h inverse of x. Now can you tell me the domain of this cot h inverse of x? Domain will be, so for the previous one, range, see here, minus infinity to minus 1 union 1 to infinity. So this is the domain of whose inverse function, and where range will be r minus 0 only, because so you observed cot hx graph in its domain, that graph was strictly decreasing, no? So as you know, strictly increasing and strictly decreasing functions are always bijective. So if the function is bijective, as you know, it is invertible. Invertible means inverse of the function is existed. Okay. Hence, okay. So this will be the domain. Okay. Whereas this will be the domain. So actually this was a range for the hyperbolic cotangent function. But when you go for whose inverse, this will come as a domain and this will come as a range. You know that. Okay. So in our previous classes also I talked to you. So if f is a one bijective function mapping from A to B, then whose inverse will map from B to A. F is a bijective function from A to B, then whose inverse function? F inverse will map from B to A. Okay, when this inverse is possible, whenever f is bijective. Okay, so now A is the domain, B is the range for f. But whereas f inverse, B is the domain, A will be the range. Right? Now let us go to whose graph. How do we get a graph of this cot h inverse of x? So now observe this graph of cot h inverse of x. X dash, y dash. Now what is the domain? Minus infinity to minus 1. Here you may get minus 1, here you may get 1. Okay, minus infinity to minus 1 is the domain. And whereas range r minus 0. So can you expect the graph? See, you get like this. Okay, r minus 0. This is minus 1. So it will go like this. So here 1 to infinity. How do we get 1 to infinity? See, you get the graph like this, very close to x-axis but never touches the x-axis. This is the graph of cot h inverse of x. So through the minus 1 through the 1, if you draw the vertical line, that vertical line should not touch or intersect this curve. Okay, students. Here, this is 1. So this, what is the equation of these lines? This is x equal to minus 1 and this is x equal to 1. Both are asymptotes for this cot h inverse of x graph. Okay, students. See here, minus infinity to minus 1. Graph will come like this, and 1 to infinity. Your graph will come like this. You know, cot hx is a decreasing function in its domain. Hence, whose inverse function also will be decreasing. So, where we are getting breaks at x equal to here 0. In its range, it should not contain the 0. Now see the domain where you got the break, -1 to 1. Okay students, I hope you have understood this. So this is a graph of cot h inverse of x. So minus infinity to -1 like this you will get, and 1 to infinity like this you will get. Where you got the break? In the range 0. It goes like this. It is very close to x-axis but never touches. It is very close to x-axis but never touches, because on the x-axis y value is 0. Y means here range. Y represents range, x represents domain. In the domain -1 to 1, no graph. So in the range 0. So 0 is not included, because on the entire x-axis y value is 0. Hence we got the break on the x-axis. Okay? Right. Now what is this? Graph of cot h inverse of x. Cot h inverse of x. Now let us go to expression of this cot h inverse of x in terms of log. How we have to express? Now let us see. Y equal to cot h inverse of x equal to, e power x plus e power minus x by e power x minus e power minus x. So e power x, this can be written as 1 by e power x by e power x minus 1 by e power x. When you take cross multiplication, you get e power x whole square plus 1 by e power x whole by e power x whole square minus 1 by e power x. Both are get cancelled. Okay. Hereafter, now let us take e power x equal to k. Now y equal to k square plus 1 by k square minus 1 you will get. Now take cross multiplication. Y k square minus y, which is equal to k square plus 1. Now transfer y to the right side, bring this k square to the left side. So y minus 1 into k square, now which is equal to k plus 1 you will get. Right. In the next step, k square is equal to, when you transfer this one right side, see here what do we get? Sorry, when we take this minus y right side, here plus y. When you bring this one left side, take k square common, y minus 1 into k square is equal to y plus 1 you will get. Now k square will be y plus 1 by y minus 1. Okay students, see here, see once again I explain you this. Now f of x is equal to, cot h inverse of x is equal to y you have to take. To express this cot h inverse of x in terms of y, to express this cot h inverse of x in terms of log, you would have to consider this cot h inverse of x equal to y. But in the previous one, I took x now, so consider this as y. Okay, now transfer this cot h inverse to the right side, so that you will get x is equal to cot hy. Now write the definition of cot hy. This is correct. So e power y plus e power minus y by e power y minus e power minus y. Now e power y plus 1 by e power y whole by e power y minus 1 by e power y. Now take cross multiplication and go for simplification. What do we get when you take cross multiplication? E power y whole square plus 1 by e power y whole by e power y whole square minus 1 by e power y. E power y get cancelled. Okay. After this, what do we get here? X equal to e power y whole square plus 1 by e power y whole square minus 1. Okay. Hereafter, so let us take e power y is equal to some k. When you take e power y as k, then x is equal to k square plus 1 by k square minus 1. Now go for cross multiplication. X k square minus x, which is equal to k square plus 1. Now transfer minus x to the right side, bring this k square to the left side, so that you will get x minus 1 into k square, which is equal to x plus 1 you will get. Now bring it to the right side. Now k square is equal to x plus 1 by x minus 1 you will get. Okay, hereafter. So transfer this square to the right side, so that what do you get? X plus 1 by x minus 1 whole power 1 by 2. Now k is nothing but we took as e power y, no? E power y is equal to x plus 1 by x minus 1 whole power 1 by 2. Now transfer e to the right side, so that you will get y is equal to log of e. So x plus 1 by x minus 1 whole power 1 by 2. As per the power of logarithm, so this 1 by 2 will come over here. Okay, I hope you have understood this simplification. So in the next step, when you take here, apply as per the power of logarithm formula, this 1 by 2 will come over here, so that y is nothing but what? Cot h inverse of x is equal to, when you take 1 by 2 here, 1 by 2 of log e x plus 1 by x minus 1 you will get. So that is the definition of cot h inverse of x in terms of log. Right. So till now what we have done? We have discussed cot hx graph and cot h inverse of graph. Okay. And while I was explaining you about those graphs, I discussed with you whose domains and ranges. Okay. And we have seen whose definitions. Now I am going to discuss with you and differentiation and integration formulas, okay, for this cot hx function and whose inverse functions. Okay, now what is the fundamental definition of cot hx? Let it be f of x, so which is equal to e power x plus e power minus x by e power x minus e power minus x. Okay, before I explain you this differentiation integration, now let me explain you whether it is an even function or odd function. Okay, to check that, what we people have to do, we have to replace x by minus x. Now replace x by minus x. X by minus x. Now go for simplification. What do you get? E power minus x, minus of minus plus, e power x by e power minus x, minus of minus plus, e power x will come. Thereafter, so from the denominator take minus common. When you take minus common from the denominator, so what do you get? E power minus x plus e power x by e power x minus e power minus x you will get. This minus you can write in the numerator place. So here this numerator can be written like this also, e power x plus e power minus x by e power x minus e power minus x. But before here, this minus 1 you can write here. What you people got? Same function is repeated. Same function is repeated. Am I right, students? See, this is nothing but what? Minus f of x. So we prepared f of minus x. Finally you got f of x. If a function satisfies this relation, as you know, that is an even function. Okay, so even functions are symmetrical about y-axis. So observe that point. So cot hx is an even function. And find whose differentiation. What is the derivative of cot h inverse of x? D by dx of cot h inverse of x is equal to d by dx of, tell me, e power x plus e power minus x by e power x plus, tell me students, e power x minus e power minus x. How do you do this? It is in the form of u by v, no? So, okay, apply the u by v formula. So here, v we have to write as it is. Okay, and what is the differentiation of this u? E power x minus e power minus x you will get. You know, u by v rule. V I wrote as it is. I am doing the differentiation of u. E power x derivative e power x. E power minus x derivative minus e power minus x you will get. Because e power x, this is not x. I followed the chain rule so that I got this. Next minus, tell me, v you have to write, now you have to write aside and you have to do the derivative of this v. So what do you get? Into e power x plus e power minus x you will get, whole by e power x, e power minus x whole square you will get. Now simplify the numerator. What do you get? Tell me. See, take the product of these two. So here, what do you get here? E power x, e power minus x whole square minus here both are positive, no? So what do you get here? E power x plus e power minus x whole square, whole by, so e power x, e power minus x whole square. Now, how the numerator is looking like? A minus b whole square minus a plus b whole square, which is equal to minus 4ab you will get. So you know this simplification, a minus b whole square minus a plus b whole square, which is equal to minus 4ab. So minus 4, a value e power x, b value e power minus x by e power x, e power minus x whole square you will get. Now this e power x, e power minus x becomes 1. Base is same, no? Add the powers. E power 0 will come, which becomes 1. Now write. This 4 if you bring to the down, what do you get? Minus 1 by, when you bring this 4 to the down, so you can write like this, e power x minus e power minus x by 2 whole square. So this is nothing but what? Sin hx. Am I right? Sin hx whole square. Okay, this is nothing but sin hx. Sin hx whole square is there. When it goes to the numerator, minus cosec h square x you will get. So this is the differentiation of cot hx. What is the differentiation of cot hx? Minus cosec h square x. Now let us go to differentiation of whose differentiation of this cot h inverse of x, d by dx of cot h inverse of x. So in terms of log, what you got? D by dx of 1 by 2 of log x plus 1 by x minus 1. Now write this 1 by 2 outside. So that what do you get? 1 by 2 d by dx of log x plus 1 by x minus 1. Now 1 by 2. So what is the differentiation of log x? 1 by x plus 1 by x minus 1. You know, log x derivative 1 by x. Is this x? No, follow the chain rule. If you follow the chain rule, so okay, do the derivative of this log x 1 by x. Now I am doing this x differentiation. So here u by v, x minus 1 into derivative of x plus 1, which becomes 1, minus keep x plus 1 aside and do the derivative of v. So what do you get here? 1 only, no? 1 whole by x minus 1 whole square. Now simplify that. So if you simplify, now what do you get? So this x minus 1 will go into the numerator. 1 by 2 of x minus 1 by x plus 1, and here x minus 1. Now here minus x minus 1 whole by x minus 1 into x minus 1. Now students, tell me, both are cancelled. This one and this one cancelled. Now what is left? 1 by 2 of 1 by x plus 1. So here minus 2 by x minus 1. Now these two also cancelled. Now what is left? In the numerator minus 1, denominator x plus 1 into x minus 1, x square minus 1. Okay, when you take minus common from the denominator, minus 1 by 1 minus x square. Okay students, now write, both are cancelled. 1 by 1 minus x square. So what is this? Differentiation of cot h inverse of x. Okay, so you know here what is the condition for x? X will be minus infinity to minus 1 union 1 to infinity. Okay students, observe that point. Right. Next, let us go to one more function, that is hyperbolic secant function. Okay, so now let me explain you whose definition. F of x is equal to secant hx. So right, see, secant hx means a reciprocal of cos hx. Already we discussed cos hx. Okay, e power x plus e power minus x by 2, but whereas secant hx 2 by e power x plus e power minus x you will get. Okay students, this is the definition of secant hx. Now tell me whose domain? It is defined on the entire real number set. F is a mapping from R. It will be defined on the entire real number set, whereas range will be, tell me students, so when you put x equal to 0, you are getting denominator 1. Am I right? E power 0 becomes 1, e power minus 0 becomes 1. 1 plus 1, 2, 2 to cancel. 1 you will get. So that will be the maximum in its range. If you substitute other than 0, okay, for x, your denominator value is more than the numerator. Am I right? If you assign x equal to other than 0, either it may be positive, see here, domain, set of real numbers. It contains 0 and positive reals, negative reals. On keeping x equal to 0, you got the range 1. If you write x equal to other than 0 means either that may be positive real number or negative real number. Your denominator quantity is more than the numerator. Hence, that division will be given, okay, smaller than 1, but more than, 0. It never be 0, no? Open interval of 0. So this result will be 0 to 1. Okay, there is no chances to get negative value here. So that positive quantities only will come. And that too maximum value 1. So that this will be the range for this secant hx. Okay. So here whose definition is reciprocal of cos hx. 2 by e power x plus e power minus x. Domain is set of real numbers. Range open interval of 0 to closed 1. Now let us go to whose graph. Now see whose graph. x dash, y dash. Now in the range maximum value is 1. So this is origin. This is positive reals and this part is negative reals. So when we write x equal 0, it attained 1. Okay, secant hx. 2 by e power x plus e power minus x can be written as 1 by e power x. If you move left side, negative real numbers when you assign for this, okay, this part became 0. This part became infinity. Am I right? Students, here when you put x equal to negative infinity, 2 by e power negative infinity and 1 by e power minus negative infinity. So in the next step, okay, this part becomes 0, this part will go to the, see here, like this you will get 2 by e power infinity you will get. Am I right? So this part becomes 0 and this will go into the numerator like e power infinity. So 2 by e power infinity means almost this approaches to 0. Almost approaches to 0 means here your graph will come like this. It is very close to negative x-axis but never be 0 because on the x-axis your y value means range. Y value 0 but it is not exactly 0, approaching 0. So that your graph will come like this. Similarly, when you assign x equal to positive infinity, okay, so your graph will go like this. But never touches the x-axis. Observe that point. This is the graph of secant hx. Secant hx. So from negative infinity to 0 strictly increases and 1 to infinity, decreasing function. So when you want to discuss whose inverse, as we know, that function should be bijective. But here it is many to one function. Okay, here increasing, decreasing, no. So that it is a many to one function. So that when you want to discuss about whose inverse function, you have to consider this open interval of 0 to infinity as principal domain. For this secant hx, you can close it, no problem at all. Closed 0 to infinity is the principal domain for secant hx. Here secant hx. Okay, right. Now let us go to whose inverse function. Whose inverse function. Okay. Now let us discuss whose inverse function. Secant h inverse of x. Tell me, what about its domain? Tell me the domain of this function. Principal domain. Okay, see, in the range, as you know, what is the principal domain of secant x? As I said to you, a closed interval of 0 to infinity. And whereas range, open interval of 0 to 1. Actually, domain of secant hx is set of real numbers, but treat this as principal domain to define secant h inverse of x. And for secant h inverse of x, this will be the domain 0 to 1. And whereas range, closed interval of 0 to infinity. Okay, all right. Now let us go to whose graph. Right, see students, graph of secant h inverse of x. X dash, y dash. Now domain 0 to 1. Here 0 and here you may take 1. This is 1. Okay. Now, when you write exactly 0, see, you get the graph like this, very close to y axis, but never be y. Okay. Sec and hx graph you observed. Okay, that graph was decreasing now in the positive interval, 0 to infinity, and whose inverse is also will decrease. Like this it will come. So this is the graph of sec and hx. It is continuous. Okay, students? Right. See, in the negative interval, if you treat minus infinity to 0 as principal domain, so like this you will get in the negative interval. But either you prefer this or this for the graph of sec and h inverse of x. This is preferable. Okay, if you go to any books, you will find this as domain for sec and h inverse of x, and this as a range. Okay, students, but for the sec and hx, so this we prepared as a principal domain. No? In place of this, if you take a negative interval minus infinity to 0 as principal domain, in which your inverse function will come like this. I hope you have understood this sec and hx graph. Now let us go to sec and h inverse in terms of log. Define sec and h inverse of x in terms of log. For that, what you need to do? So this one you have to consider as y. Now send sec and hx to the right side, so that you will get sec and hy. Now what is the definition of sec and hy? 2 by e power y plus e power minus y. Okay, right. Now what do you get? Tell me, students. 2 by, if you simplify e power minus y, write as 1 by e power y. And in the simplification, e power y will go into the numerator, and here e power y whole square plus 1 you will get. So in the next step, consider e power y as k. If you take this is k, then it will become x equal to 2k by k square plus 1. Now simplify that. Take cross multiplication. X k square plus x, now which is equal to 2k. Now, okay, students, here we want k. For that, what you have to do? Bring this 2k to the left side. X into k square minus 2k plus x, which is equal to 0. Now it is a quadratic equation in terms of k. Now k is equal to minus b plus or minus, but here take only plus, because you have observed whose e power y. K means e power y, no? So this is always positive value. So that here you prefer only plus formula. Okay, in the quadratic formula, minus b plus or minus, but prefer plus symbol only. B minus, b value minus 2 plus root of b square 4 minus 4ac. So minus 4x square you will get. A value x, c value also x by 2a, 2x. Minus into minus plus. So e power y, which is equal to, what do you get here? Students, tell me. 2 plus root of, take 4 common. When you take 4 common, so your root of 1 minus x square by, so 2x you will get. Now take 2 common from the numerator, cancel with the denominator. E power y equal to 1 plus root of 1 minus x square by x. Now x, transfer e to the right side, so that here you will get log of 1 plus root of 1 minus x square by x with base e. So this is a sec and h inverse of x value in terms of log. Sec and h inverse of x is equal to log of 1 plus root of 1 minus x square by x with base e. Okay, students? Right. So, even this secant hx is also an even function. Okay? So, because to find whether it is even or odd, what you have to do? Replace x by minus x so that you will get same function, hence you can say that it is an odd function. Okay? So, this many points from secant hx and secant h inverse of x are enough okay, for competitive exams. Now, let us go to the hyperbolic cosec function. So, you know, cosec hx is also can be called as a reciprocal of sin hx. So, cosec hx definition is 2 by e power x minus e power minus x. Now, tell me whose domain? Tell me whose domain? Okay, should not contain a real value, because if you write x equal to 0, your denominator part is going to become 0 now. So that remove 0 from the set of real numbers, that will be called domain. And whereas range, speak about whose range, what do you get? If you assign any real number, positive real number and negative real number, what do you get to tell me? Secant. Tell me, students, what do you get? Is there any chances to get 0 in the range? No chances. So that in the range of this cosec hx also will be r minus 0. See, students, here 2 by e power x, it can be written as 1 by e power x. No chances to get this range as 0. So that I removed 0. Other than 0, okay, it can be given positive real numbers, all negative real numbers. Because suppose if you write so x equal to a positive infinity, this part becomes 0 and the rest of the part approaches to 0 but not 0. If you assign x equal to negative real numbers, negative infinity, if you write this part becomes 0, this approaches to 0. Means finally it becomes very close to minus 0. Sorry, very close to 0. Okay, I will show you in the graph. So, for the cosec hx, domain is r minus 0, range is also r minus 0. Now, observe whose graph. X dash, y dash. Okay. One by e power x. Students, tell me, how do we get? If you keep on increasing x values, suppose if you assign x equal very big value, this part becomes 0, you know. Here 2 by very big value approaches to 0. See, you get the graph like this. This is y-axis. Okay, if you give any x value very near to 0, like 0 0.1, 0 0.5 or 1, so this part becomes very big value. Like that, if you keep on increasing your domain values, so your denominator is going to be very big. Hence, this result will become 0, but never 0. Very close to 0 range. Okay, approaches to 0, but not exactly 0. Hence, you get this kind of curve in the positive interval of its domain. What is the domain of cosec hx? R minus 0 to R minus 0. Now in the domain place, I kept positive real values, so that I got range also positive. real. Similarly, when you write negative domain values, you get the graph like this. Range never be 0, domain also never be 0. You get the graph like this. Okay, this is also strictly decreasing function. Graph of cosec hx. See, observe the domain, observe the range. You get the graph like this. So domain x-axis, we have not given a 0 in the domain, so that you got the break at 0. In this graph, you got the break at 0, no? So go to the range. Range also very close to y-axis, very close to y-axis, but never touches the y-axis. If the curve touches the y-axis, as you know, whose y value becomes 0. So not touching. Okay, I hope you have understood this cosec hx graph. Now let us go to whose inverse. To discuss this inverse function, what you people have to do? Whose inverse also r minus 0 to r minus 0. Why r minus 0 to r minus 0? Because in the cosec hx graph, okay, that graph was strictly decreases, no? Not like secant hx. Secant hx graph many to one function, not bijective. So that we preferred principal domain and we have drawn whose graph. But whereas for this cosec hx, in the negative domain also, that is strictly decreases. In the positive interval of domain also strictly decreases. As we know, strictly decreasing function is a bijective function. Bijective means in its domain it is invertible, means inverse function is existed. Okay, now let us discuss about this cosec h inverse of x, okay, definition and whose graph. Okay, so this cosec h inverse of x, okay, domain r minus 0, and whereas range is also r minus 0. Okay, right. Yeah, now let us see whose graph. How do you get graph? Same like, okay, cosec hx graph only we will get, because domain and range is same, no? Domain and range is same here also, so that you get this kind of curve only. Cosec hx and cosec h inverse of x, both graphs will be same, because no changes are getting in its domain and ranges. Okay, so this is the graph of cosec h inverse of x. Cosec h inverse of x. Okay, now let us define this cosec h inverse of x in terms of logs. Okay, for that what you need to do? Let us take this is equal to y. Now when you transfer cosec h inverse to the right side, it will come as cosec hx, cosec hy. Now define it. So 2 by e power y plus e power minus y. Now 2 by e power y plus 1 by e power y. Now here when you simplify this, 2 e power y by e power y whole square plus 1. Now cross multiply. So x into, let us take e power y equal to some k. So that what do you get? X equal to 2k by, what do you get, amma? K square plus 1. Now simplify. When you simplify, so tell me students, what do you get? Cosec, no, your middle minus will come. We are discussing cosine function now, reciprocal of sine, here middle minus will come, minus. Here also minus. Okay students, right, here minus. Tell me, when you take cross multiplication, x k square minus x, which is equal to 2k. Yes. Now bring it to the left side. So x k square, when you bring this one to the left side, minus 2k, right here minus k, minus x, which is equal to 0. Now k is equal to, okay, k, tell me students, k is equal to what do you get? it is a quadratic equation in terms of k, no? Now k is equal to e power. So you know quadratic equation in terms of k equal to, apply that quadratic formula, minus b plus or minus, okay, root of b square. B square means, students, here 4 minus 4ac, 4x square you will get, whole by 2a, 2x. Okay, students, actually, okay, k means what, students? Here e power y we took, no? Right. So here simplify this. In this simplification, what do you get? 2 plus or minus, take 2 common, 1 plus square root of 1 plus x square by 2x. Now take 2 common and cancel with the denominator. So here what do you get? K is equal to 1 plus or minus root of 1 plus x square by 1 plus x square by x you will get. Now students, tell me, what is k? E power y, now which is equal to, right, 1 plus or minus root of 1 plus x square by x. Now transfer e to the right side, so that here you will get log e 1 plus or minus root of 1 plus x square by x. Okay, so y is equal to what? Cosec h inverse of x is equal to log of e 1 plus or minus root of 1 plus x square by x. Now here you may get a doubt. When we have to take this is plus, when we have to take that is minus. Okay, see, when x value is minus infinity to 0, so you know what is the domain of cosec h inverse of x? R minus 0 means which includes negative x values and positive x values in its domain. So here in the simplification you got here plus or minus. So when you have to take minus, if x belongs to minus infinity to 0, okay, so here you have to prefer minus log of 1 minus root of 1 plus x square by x. And when you have to take minus, sorry, here minus we took in the minus infinity to 0. If x belongs to this interval means it is negative, then here you have to prefer a negative symbol. And if x belongs to 0 to infinity, then your cosec h inverse of x result will be, so log of 1 plus root of 1 plus x square by x. Okay, students. So this cosec hx and cosec h inverse of x are also not periodic functions. Okay, even cosec hx and cosec h inverse of x are also, okay, an odd function. Okay, so you know, if you put x equal to minus x, you will get minus f of x. Hence you can say them as odd function. And if you would like to find whose differentiation, so you know, you can able to find like this here. Okay, here cosec h inverse of x. Suppose if you would like to find whose differentiation, so what you have to do, students? Now observe the x. If you x is positive, then take this d by dx of log of 1 plus root of 1 plus x square by x. Now go for whose derivative? Log x derivative, your base is e, 1 by 1 plus root of 1 plus x square by x. Now v is this x? No, follow the chain rule. So u by v. U is this 1 plus root of 1 plus x square. Keep it aside and do the derivative of 1 minus x into, do the derivative of u, 0 plus 1 by 2 root 1 plus x square, and here 2x will come, whole by So whole square, here x square. Okay, now simplify. This x will go into the numerator. X by 1 plus x square. Okay, now simplify this. 1 plus root of 1 plus x square, and here 2 cancel. Okay, so what do you get, Amma? X square by root 1 plus x square whole by x square. So in the next step, so here outside x by 1 plus root of 1 plus x square. So inside, when you take cross multiplication, root 1 plus x square, and here when you take cross multiplication, 1 I am multiplying with this, so that I got. Next I am multiplying these two, 1 plus x square minus x square whole by x square into root 1 plus x square. Now simplify that. Right, what do you get here? These two are get cancelled. Now what is left? 1 plus root 1 plus x square, and these two will be get cancelled. And 1x I am cancelling with this 1x. Okay, so what is left finally? 1 by x plus root of 1 plus x square is the derivative of cosec h inverse of x. Observe that where x belongs to 0 to infinity. Okay students, like this you have to find whose derivative. And also, if you would like to find whose integration, if x is belong to positive real, so 1 by x of root of 1 plus x square dx is equal to, what do you get? Cosec h inverse of x. Even also it can be written as log e. Tell me here, what you got? 1 plus root of 1 plus x square by x you got, no? So I think here it is x. X? No, 1 only. Okay students. So this is the integration of this 1 by x plus root of 1 plus x square. Actually this was differentiation of cosec h inverse of x. But when you find whose integration, you will get cosec h inverse of x. You know, reverse process of differentiation is known as integration. When you do the differentiation of cosec h inverse of x, this much you got. When you find whose integration, again you will get cosec h inverse of x. Okay students, thank you one and all.